This video is on key features of a function. We are doing example 4. The physics class is doing experiments with model rockets. They placed an electronic chip inside the rocket that records the height after it has been launched into the air. The data from the chip is displayed in the graph below. So we can see that the model rocket starts here and it goes up and then it does come back down because model rockets need to go up and come back down. They do not go on forever. Our first question says to estimate the height after 5 seconds. So 5 seconds, seconds is on the x-axis. So at 5 seconds, we can follow this up to the graph, and then we can follow it over to the left side to get to our y-axis. Looks to be at about 80 feet. So the estimated height after 5 seconds is 80 feet. Estimate the height after 2.5 seconds. Well, this is 2 seconds, that's 3 seconds, so 2.5 would be somewhere in the middle here, and we can again follow this up to the function, and then follow it over to the y-axis. So at about 2.5 seconds, following this up the middle, looks to be at about 140 feet. So, what this means, both of these questions mean, is after 2.5 seconds, the rocket is 140 feet above the ground. Then it actually keeps going, and it comes back down, and at 5 seconds is 80 feet in the air. When will the height be approximately 40 feet in the air? So at 40 feet, so height in feet, we're going to look at the 40, that's on the y-axis. We're going to see how many times it crosses. There's once here, but then it also hits again at 40 feet here. So the question is, why are there two answers as well? So we can see that it hits 40 feet at about 0.5 seconds, and then again at roughly 5.5 seconds. So we'll say 0.5 and 5.5 seconds. Now, why are there two of them? Yes, it does hit twice, but why does it hit twice? So this happens twice because the rocket goes up, it hits its peak, and then it comes back down, and it hits, since it's starting at the ground, it has to hit the 40 feet going up, then it's going up even further, but then it has to come down and then it will hit the ground. So it has to pass the 40 feet again. So the rocket, it's because the rocket goes up and then has to come back down. Has to come back down. And it will hit the 40 feet on both times because it started at the ground and then it will end on the ground. Find the maximum and explain its meaning in the context of the problem. So remember, the maximum is the most amount. So where is the highest point that this rocket will reach? And remember, the maximum value is the y value. So if we find that maximum location, so clearly it's not going to be here because it keeps going up. It keeps going up, 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 and then it stops, and then it'll start coming back down. So this is actually the highest point it'll reach. This is at 3 seconds, but at 140 feet in the air. So the maximum value is the 140, looks to be at about 145 because it's a little bit above 140. So we can say roughly 145 feet. That's our maximum. So in the context, this is a rocket, that's the highest height that the rocket will reach. So the highest the rocket will ever reach is 145 feet. And it actually reaches that after 3 seconds in the air, because then after 3 seconds it starts coming back down. Find the y-intercept and explain its meaning in the context of the problem. So again, the y-intercept is where it crosses the y-axis, which is down here. So the y-intercept is 0, 0, which is at 0 feet. So I'm going to put 0 feet. And what does this mean? So the y-intercept is when it has not been launched. So at 0 seconds, the rocket is 0 feet above the ground. So that also tells us that the rocket is being launched from the ground. Find the x-intercept or intercepts and explain its meaning in the context of the problem. So the x-intercepts are when it crosses the x-axis. So here's our x-axis. And when does our graph hit the x-axis? Well, we know it hit here, but then it also goes up and it comes back down here. So these are at, the two x-intercepts are at 0, 0 and at 6, 0. 0, 0 is that first coordinate where it starts, but then 6, 0. This is a coordinate 6, 0 because remember, coordinates go x, then y. This is 6 on the x-axis and then 0 on the y-axis. Now, what does this mean in the context of the problem? This is at 0 seconds. The rocket is 0 feet above the ground. And at 6 seconds, the rocket is 0 feet above the ground. So at 0 seconds and 6 seconds, the rocket is on the ground. Now let's think about this another way. It started out here on the ground and then it flew. It went up and then it came back down. So what else does that 6 seconds mean? It was in the air at 1 second and at 2, 3, 4, 5, but then it was on the ground at 6 seconds. So we can actually say that it took 6 seconds for the rocket to land. It took 6 seconds for the rocket to land. The next question is, when is the function increasing? So as we look at our function, starting on the farthest left, we want to follow this shape, and when is it going up? So as we start going, it is moving up because our rocket is going up into the air, and then it reaches a peak. Then it starts coming back down. So now it's decreasing as the x's are moving forward. So it's increasing from 0, the x value of 0, until we get to that x value of 3. Again, I'm not looking at the y's. I want to know as the x's are moving, my graph is going up. So it's from the x value of 0 until the x value of 3. So it's increasing from 0, x is in between from 0 to 3. So from 0 to 3 seconds. And then when is it decreasing? So again, we can look back where it stopped increasing at that peak, and then it started coming back down. So the peak was at 3 seconds, and then it kept coming down until it landed on the ground at 6 seconds. So it's no longer increasing or decreasing because it's just landed. So we can say from 3 seconds, so x is in between 3 seconds and 6 seconds. So from 3 to 6 seconds, it is decreasing. The graph is coming back down.